right, well, I hope everyone's doing good. Let's take a look at Unit 1, which is simply called Essential Ideas. So the main question is, what is chemistry? And there's three parts to this definition. I'm going to break them all down for you. So it's the study of the composition, the properties, and the interactions of matter. So the first part here we need to break down is this word composition. So composition is essentially saying how they are made up, right? So the composition of matter. So what type of atoms are there? And then we deal with the properties of those individual groups of atoms. And there are a million different properties you could list. So I'll just list a few. Like their melting point or their boiling point, whether or not they conduct electricity, right? Whether they're hard, whether they're soft, so on and so forth. So just different physical and chemical properties. And finally, interactions, right? So, when you hear the word interaction, yes, you think about chemical reactions, right? So when you interact two different compounds together, right? Will there be a chemical reaction? Will you see smoke? Or will there be a chemical change of some type, right? And so chemistry is comprised of all of those different components, all right? And so now let's go on a little bit further and think about some more things. Let me erase this. I'm getting used to this little platform here. All right, moving on. Chemistry is the central science because it is the center of many fields. And you can see that from this diagram here. It's pretty cool. So as you see, chemistry is right here in the center. Again, it's called the central science. And a lot of different fields that you can think of are branches of this topic, right? And so, for example, a lot of students enjoy biology from their previous year, right? And so you see biology over here. But what you have to understand is that biology is a branch of the study, or a branch off of the study of chemistry, right? And so in biology, you talk about cells and so on and so forth. Well, cells operate in somewhat of a chemical manner, right? I mean, cells are made up of chemicals, and we study that in chemistry. And so you might think of something else like medicine, right? Or physics, right? There's a lot of math in science, and there are different topics in chemistry that are critical to understanding before you study physics. Likewise, math, computer science, nanoscience technology. Really, it's to the point that if you can think of it, it is probably going to be some sort of a branch of chemistry. So that's pretty cool. So chemistry is what we call the physical, or the central science. And we view the macroscopic world. So you need to understand these two definitions. The word macroscopic is the big scale. The big scale. In chemistry, we view the macroscopic, or the big scale, in a microscopic, so the small scale, in a microscopic way. And I'll explain that to you in this upcoming slide. I think you'll find it pretty interesting, right? So let's go ahead and do that. So we have the macroscopic versus the microscopic, right? So again, the macroscopic is the big scale, or the world, right? It's everything that you can see. And as you see here in this image, right, we have all three phases of H2O, of water, right? We have it in the gaseous form through the clouds. We have it in the solid form through the ice, and the liquid form, obviously, through the water. But in chemistry, we look at the big scale, the macroscopic, the things we see in everyday life, and we analyze the composition, the properties, and the interactions of those groups of atoms that make up the macroscopic. And that's called the microscopic, right, which is the atomic level. So in chemistry, we take a look at the big things that we're used to in everyday life, and we think about what makes them up and their properties. Again, that's the microscopic, or the small scale. And so we can see here that in reality, right, the water vapor, or the gaseous H2O, is or it has different properties, you could say, as the ice or the liquid water, right? As you can see here, looking at the individual water molecules in a gas, they're spaced apart more than they are, say, in the liquid. So they have different properties. And sure enough, right, we know that water vapor is different from liquid water in some way. That is just by analyzing it on the macro scale. But looking at the micro scale, right, you can see why those differences are there at the atomic level. So it's pretty neat stuff. Let's go ahead and analyze the 6 main branches of chemistry, right? And we're going to go ahead and start with organic chemistry. In some ways, it's probably the one that you're most familiar with, but you just don't realize it. And so in organic chemistry, we study mostly carbon-containing compounds, right? And so I have some different examples for you, right? Plastics and polymers. Now, the reason I included that on there is because a lot of our plastics or polymers are derived from petroleum, right? So the crude oil, you could say that is mined from the earth, right? And history tells us, right, and science more so tells us that a lot of the oil in the ground is old, decayed, either animal or plant matter. And so that contains carbon, right? Carbon-containing compounds, for the most part, you'll have teachers tell you living things, right? So organic chemistry deals with living things or once living things, and all living things contain carbon. So another example, pharmaceuticals, right? You'll see that big time if you were to take a college level organic chemistry class, right? But all these things are applicable to you. And of course, carbon is the base of living things. So here is a living thing, a plant, right? And for all you ladies out there, the world of cosmetics, right, is just a bunch of organic compounds. Do some research on it, and you might stop using them when you see where some of your cosmetics come from. But all these are applications of organic chemistry that you're familiar with, or at least that you use or you interact with in your everyday life. And other compounds that are common in organic chemistry is hydrogen and oxygen. But just realize, really, organic chemistry is the study of carbon-containing compounds, that is, of living things or, once living things, right? But hydrogen and oxygen are also popular elements in this subject. So moving on, biochemistry kind of branches off from organic chemistry. You have to understand organic chemistry to understand biochemistry. So biochemistry is pretty much the study of processes that go on in all living things, right? And so some examples, right? This is DNA, right? And again, made up of cells, which again, made up of chemicals, and you have to understand how those chemicals interact. And the way they interact, obviously, is important because it determines what DNA does, right? And so, again, you have a picture of a cell. Again, all these little functions that go on in a tiny cell, they're chemical-driven, which is chemistry, right? And in biochemistry is the specific branch in which you study that in great detail. See, the class that you're going to take with me is kind of a scope of all of these branches of chemistry to get you familiar with it when you move on and potentially specialize a little bit later. And you have proteins, right? In this last picture, you have your protein sequence of all your different amino acids. Again, they're made up of chemicals, but these come together and they form these highly complicated protein structures, right? Which we'll talk about again when we visit the theoretical chemistry branch in just a second. These get so complicated you have to have very powerful computers to model these. So biochemistry, processes that occur in living things, right? And you have to remember the key idea here, biological processes are chemistry driven. Again, chemistry is the central science. The next branch is the exact opposite from organic chemistry, right? In organic chemistry. And so now we're not going to so much deal with carbon. And there might be a couple carbon atoms in some of these materials or compounds that we study, but for the most part, it is to deal with things that are not living, as organic was living, or at least once living. So, and some examples, metals and minerals, right? And you have a semiconductor in this case. So you have a computer chip, a computer processor. Lord knows They are a big, probably one of the more booming aspects of inorganic chemistry is the tech industry, right? Here you have a mineral, right, that you can find in the earth, and here you just have, good old, metal pipe, right? And so inorganic chemistry is a very, very huge and applicable field to everybody today, all right? Another branch, this happened to be my favorite branch in college. This is called analytical chemistry, right? And now, if you ever have seen these pictures of a mad scientist holding up a beaker and staring at it, in some ways that's a good picture to summarize analytical chemistry, because we're identifying either the components of a chemical. So say we are forensic investigators and we find an unknown substance. Well, the job of an analytical chemist would be to use different pieces of equipment as well as just chemical processes to try to identify what it is, what it's made of, what's the concentration of the main ingredient, how do you synthesize this, how do you synthesize it better, how do you break it down, all of these different things. So the identification and the components and composition of materials using chemical processes as well as equipment, right? And so this piece of equipment here I've used many times is AA, absorption spectroscopy, and we might go on into that just a little bit in this class if we have time, right? So analytical chemistry here is used in a bunch of different interesting applications, all right? Okay. PChem, physical chemistry. So, in my class, you're going to learn a lot of different ideas, right? But I'm going to teach you the theory and the concept behind it, right? Not near as in-depth as the theory would be taught in a physical chemistry class. But in a PChem class, they teach you the math behind everything, right? So in my high school chemistry class, you're going to learn about electrons and electron configurations and different rules and principles that govern how those go, right? But in PChem, you prove it using calculus and differential equations and hardcore theory. So as you can see, I tried to find some different pictures here. The one on the left of a wave function, and the one on the right, the ultraviolet catastrophe that was finally broken, I guess you could say, or studied further by Max Planck, which we'll talk about later in this class, right? And to me, this is the most difficult class I ever took in college by far, right? And finally, theoretical chemistry. Now, some people will tell you that there aren't 6 branches. Some might say there are less. Some might say there are more. But what you have to understand is as time goes on and discoveries increase and technology improves, different branches of science are going to be founded, right? And theoretical chemistry happens to be one of the newer branches because now we have computers that are very high tech, and we can use those to model, predict, and analyze different chemical structures and properties. So like that protein that I mentioned under biochemistry, right? Those are really complex for different reasons. And now with the power of supercomputers, we can do some really neat things as far as how different drugs will interact and bind with them, and what effect they might have on us, and so on and so forth. And it's pretty cool stuff, right? So this has been a study and overlook of what chemistry is and the 6 branches that you will see in some shape, manner, or form as you go along in your studies. And I hope you find it enjoying and interesting, and thank you for watching this.